So today I'm going to review this Fluke 289. This is a logging multimeter. As you can see, it's got a graphical display and all sorts of stuff on it. Very nice. This has been sent to me at no cost by Fluke and Pomona. So thank you very much Fluke and Pomona for supporting the channel and sending me items to review at no cost. Brilliant. Let's get into it. This meter is actually brand new. It's got an August 22 manufacture date, which is, it's still August now. It's brand new. Straight from the factory to me. It's brilliant. Bunch of paperwork and stuff like that. So, statement of calibration practices. It's got some information on the back. Test data. So this is the actual calibration data. We'll have to look at some of these and see how we actually come out. Safety information. Yeah. Supplement. Okay. Licensing information. Okay. What's we got here? Let's actually have a look at this thing. Oh right, this is mentions lead and stuff like that in it. So yes, about what materials go into making the product. Here's what it is, people. Come on. Fluke card, registering the meter, and a little quick get started thing. Basic measurement tests. Right. Nano Siemens sounder tells you how to use the meter just to start off with and get you going. And that side's upside down. Told you to get into the compartment in the back there for the batteries and fuses and stuff. Nice. It's all self-explanatory. Holder. I've got some of these hangers. I've got some of those. They sent me the 7 a little while ago. So I want to use a hanger I can because I've got some. Right. And it's got like a built-in menu system and help system as well. It's actually use help built into the meter. Here is the meter. And we have some accessories. So I already had a bit of a dive around in this thing and poked around, and I did mailbag. There you go. So got some leads which are silicon leads. Nice. Got some caps that go over the leads. This is obviously for the IP rating stuff. Cat 4 600 volts. Cat 3 1000 volts. Yeah, it says the same thing on the front panel. But those go over the tops of the tips, so you can cover them. Got some clip leads. So clip on the circuits. These have got insulated tips on them. See, it's insulated there, so those are nice. They just slide on. These are some nice quality ones. Heaps of insulation. Nice tight fit. Good. So you've got a amp jack plug set. So these are little plugs which cover the jacks up. So I suppose if you're not using them, you can cover them up. Maybe it's a safety thing for flashback or something. I don't know, if you're doing high voltages, maybe you want to cover those jacks up which you're not using, or maybe just keep dirt out. You could do that too. Okay, let's put them in. So they should just poke in there. Yep, little rubbery plugs, so they help keep the dirt out. That's nice. Good stuff. So let's look at the actual leads. So like I said, these are silicon leads. It's nice to see actually, because a lot of the other meters I've been reviewing have only had PVC leads. So it's actually really nice to see that this meter's got silicon leads with it instead. That's nice, because there's a lot of criticism I've been seeing a lot on like the reviews I've been doing. When I've been reviewing other meters and I come with PVC leads, I get criticism in the comments about, you know, the fact that it's sort of cheapened out a little bit by sending PVC leads instead of silicon leads with the meters. You know, these aren't cheap meters, these are expensive, high quality meters. I think silicon leads should really be given with Fluke meters. You know, you should just get the best, regardless. We'll have to look and see how long these leads are actually. Let me find out how long these leads are. On the contents list it also shows a CD being present, and I don't have that. So I'm imagining it's done on the software of the website anyway. Yeah, I'm just surprised it didn't come with it. So the leads are about 1.4 meters tip to tip, so it's about 1.2 meters or so, or the actual cable. So that's a nice length. I say these are silicon leads, they're really nice. It's nice that you see silicon leads. Let's actually have a look at this thing. Tilting barrel on the back. Access screw. So let's get into here and actually have a look. 90-degree turn, pops it open. And there we go. Alright, the batteries are stored in the back panel here. Drawer cells. Well, watch out for that. That's what it came with. Drawer cells. Date is April 25 is the expiry date. Yeah, drawer cells. Drawer cells never good. Yeah, we'll see. That's what comes with it. And there's the access to fuses. There's the 11 amp there, and that'll be the 400 milliamp or 440 milliamp there. So you can change those without too much trouble. Nice, and it's got this foam in here to make sure the batteries stay pushed in place without getting dislodged. You have to wonder a little bit why it's got that when it's got these ridges in here too. Maybe that is a design oversight, or maybe they found different batteries were slightly different thicknesses and it's causing problems, so they decided to go with the foam. Yeah, I don't know. I don't have a problem with it, it's fine. And on the side it actually tells you the polarity of the battery, which way around it should go. It's a nice detail. And as usually the case with these Fluke meters, it's got these probe holders up here. So you can actually put, even as storage, you can store them in like that. Actually put the two in better. So you can store the probes in like that when you're using it and carry it around. You can wrap the wires around and store them. Or you can actually do things like that and shove them in, and then you can probe circuitry whilst holding the meter. It's a nice detail they have in their meters. A lot of meters do have it, but Fluke's do it quite nicely. Right, let's have a look at this thing. So we've got 4 buttons across here, which are like menu buttons, stuff like that. Obviously functions it has. Got hold, got a min max, got some arrow buttons, range, info, backlight, power button, which means you can leave it on a range you use most often and just turn the power on and off, which is nice. I'm not sure what the battery life is on these offhand. It'll be listed in the specs somewhere. I don't have a copy of those actually. I'll have to look it up. Some meters have got better battery life than others. I don't know what this will be like. Anyway, let's turn it on. So the power light does light up and it is showing on screen. Now the camera's probably not going to do this any justice, because it does tend to be a bit funny about screens, because there must be some filters or something I've got on here, and it does seem to affect them. So I can actually see the screen absolutely fine, no problem at all. All those angles absolutely fine. I can see it probably because I'm at this angle here, right? So for you, equivalent is probably about there. That's when I can't see the screen properly anymore. But yeah, view angle fine, no issues. Downwards actually looks slightly better. It's actually easier to see it that way than it is upwards. Upwards still okay, up to about sort of kind of that angle for you, I suppose. It's not bad. Turn the backlight on, and now you can see it absolutely fine, even on camera. That's good. So the backlight is actually really good on this. That's a nice even backlight too. That looks really nice. Not sure about the colour. It's like a bluish colour. I'm not a fan of blue lights. They too tend to be harder to see. But in this situation, it actually seems to suit it. It actually works okay. I think yellow one would have been nicer. Yellow backlight. So what we've got on screen here, got battery indicator, time, got date up here because it's got like a real time clock in it. Let's get a bit closer. You go, see it's slightly better now. So date over there, and you actually do setup stuff like that. So you actually have a setup menu, meter info, reset. So you can use this cursor to get around. Calibration, display, contrast settings, secure arrays, recording. There is more as well, I think. It's like, I don't know if this means cursors or what, but daytime, formatting, closing this menu system. Got menu here. Do each range. So whatever mode you're in, you can push that button and it will go into options for that particular mode. So in this case it's doing AC plus DC. That's its default, or you can do different ones as you can see across here. So you can do it with these cursors. So it's volts DC. If you're doing AC and DC, you can actually choose which displays, because you can do dual displays. So if I come over here and push DC, AC, that'll give me a dual display with DC and AC at the same time. Very nice. That's good for checking ripple on power supplies. So the only thing I don't like about this, I don't know if there's a way of actually storing the setup. So if I go back out and back into a mode, then it loses that previous setup. So if I want to have that DC and AC like I had before, like this, and I go say into millivolts and then go back, it's defaulted back to that. So I don't know if there's a way of actually getting it to retain that previous setting. I did try pushing save, but it didn't seem to actually do that particular function. It does something else, I think. I haven't read the manual, I've got no idea. I'm just playing with this thing and just seeing what it does. So anyway, let's start around here, start on low Z, and we'll see what this does. So it's volts AC, It's low Z for volts AC because it's AC only, and this is the voltage reading. It just gives a loading across the supply to, say, discharge capacitors and stuff like that, I suppose. Main thing is so you don't get stray voltage readings. So if you've got mains AC stuff, you're doing mains AC work, right, household stuff, whatever, you can pick up stray voltages which are induced in the cables from another cable. So you may be reading, you know, 60 or 70 volts in a cable, for example, but that isn't actually there. It's just purely being induced by its proximity to other cables. And so with the low Z reading means it actually puts a bit more loading on the line and helps to kill any of those false readings. That's a nice feature. Then obviously you've got the standard volts AC and options in here. So volts AC, you've got low filter cutoff, or low pass filter I should say. Peak, CF, not sure what CF is. Relative mode, hertz, percentages, milliseconds, dBm and dB volts. And also you've got the buttons here as well to choose the different options for each one. Alright, so you can just choose which one of those. It's got multiple choices, you can choose the one you actually want. Alright, let's have a look. What's CF? Ah, crest factor, of course it is. That's nice, crest factor. That's nice to know. Let's try it. So I'll just plug the leads into an AC supply. Let's turn the power supply on. Oh, backlight's gone off. 1.4 apparently. Interesting. I'm not sure what it's supposed to be. I'm not an expert on crest factors. Let's wind this up. Let's just go to an auto transformer, as you can see. And as I wind it through different voltages, that seems fine. Yeah, rearranged. No worries at all. So as it gives you a dual display, that's quite a nice feature. Now if I go back out, it's now lost that setting again. So again, I would imagine there must be a way of setting it to remember them. I mean, it would be nice. So millivolts, we've got here millivolts AC, hertz and stuff, the same as the volts range. Obviously this is the AC section. Volts DC, like I said before, we've got these different options here. Just plain volts DC, relative mode, peak mode, AC plus DC options, so you can actually do AC and DC, AC and DC, which is AC primary, DC secondary, or the other way around, which I showed you before, which is DC then AC. Which way you want as your main display. And also you've got these other options over here. Okay, and millivolts, I imagine that's probably the same options. It's got the bar graph across here as well. It's interesting why it said you're picking me up doing that. See that? Me rubbing across the screen is inducing noise in the processor, and you can see it on the bar graph. That's pretty interesting. Alright, so here we have temperature, Fahrenheit and Celsius, millivolts DC, standard displays, relative, percentage, peak, AC and DC options same as before. And those options there as well, hertz, percentages, milliseconds. Resistance mode, so we've got standard resistance, nano Siemens and a sounder. Let's have a look, see how quickly this responds. You see it ranging through. So that's a 500 ohm range. So it's a 50,000 count meter, by the way, I should point that out. So 500 mega ohms the top range and 500 ohms the low range. Kind of. There's also a second range over here. We'll get to that. Alright, menu. So ohms, now Siemens, you can switch between them. Beeper. Short option. What's this one here? So beep on open. So it's inverted. Okay. Battery resistance again, and go back to that one. Beeper that way. Now that's fairly fast, but it's not perfect. It's actually got gaps, so it's actually missing some of those hits because it's latching, and it's actually got like a delay when it resets itself. Let me get my tester out. So I've got the DMM continuity tester by Ian Johnston here. He made this open source, so you can actually get these yourself and make them yourself. Let's plug it in. So this tests the pulse time stuff that's available for the meter, right? So you've got a mark space ratio. So mark is the on time, space is the time between pulses. So basically I'm going to turn this down like I've just done until I find where the meter no longer responds to those trigger events. Basically what it's doing is switching a MOSFET which is shorting across the leads here, right? So we'll keep going up until we find it. There we go. So about 0.46 milliseconds is the pulse time to trigger it. Now it does have a bit of a pattern in it when it triggers. Don't worry about that. There's actually a firmware update is done to resolve that pattern issue, and to me it doesn't actually bother me anyway. Yeah, anyway, that's fine, it's pretty quick. It's not the fastest. This one here is the fastest. I could actually get this one to not trigger. But this is still pretty good, 0.46, that's pretty fast. Good enough I think. I think the only problem with that is that because it's like a latching one, when I was doing really quick events, it wasn't triggering on every one, it was only catching like the second one or something like that, because it wasn't responding that quickly to lost and regained triggers. If you're quickly buzzing across a bunch of pins on something, for example, you may find that it doesn't trigger as well as you'd like it to. I think that may be the thing, but it's not a big deal. It looks pretty good. The backlight stays on for a decent period of time. I'm not quite sure what the time period actually is, but it's a fairly decent time. I'll just turn it on now. We'll see how long it lasts. So we've got 233 there. Next mode, so we've got capacitance and diode mode. We need to do some testing with my calibrator on this thing. Alright, let's plug a capacitor in. This is a 200 picofarad cap. 289, 290 picofarad. That's off by quite a bit. Now, interestingly, on the actual calibration data here, it actually shows capacitance as 5 nanofarad only, as the only one they've actually got set. So, I find that kind of curious. Should have done more calibration steps than that. Anyway, so 200 picofarads off by quite a bit. Let's try it. 1 nanofarad. 1.1 or 1.15, it's not too far off. Let's try it. 20 nanofarad. 20.2, 20.1. Yeah, that's pretty close. Let's just stick with the guarding on there, shouldn't matter anyway. Yeah, fine, no difference. And then we've got 1 microfarad over here. And that's looking really close. Just one count up. So they look pretty good, apart from the bottom end, like below 5 nanofarad it would seem, which is where their calibration point is. And the actual reference here was reading very slightly high, 501. So it's alright, I suppose. If you're doing really small capacitance values, there might be a bit of a problem for you being off, you know. You don't want to have a capacitor which is, you know, 20 picofarad and you can't read it. I don't know. And the backlight's still going, it's 37 now, so it's been at least 4 minutes. Maybe it lasts 5 minutes. And you see the rubber plugs falling out. That's not a good thing. Push it back in. Diode test mode. Let's look at this. Menu. So we've got diode cap and relative modes. So, I guess you go left and right, also does up and down as well. That's kind of confusing. Anyway, diode mode. Let's have a look at that. Does it beep? It does beep. Let's get some diodes. Backlight just turned off, 38, so it must last for 5 minutes before it turns off. That's pretty good. That's a lot longer than it usually lasts. So, diodes, let's check this one. Yeah, because it's charging capacitors up, that's absolutely fine. Reverse it around the other way. Again, because of capacitors. There we go. Because I was charging capacitors up to that. Normally it would just beep. Let's do another diode. Here we go. So that's actually fairly fast. I'd say about a quarter of a second. And that's alright. And also it does say it's got a short. that seems fine. Yeah, happy with that. I'll do another dive around the other way. Charging capacitors up. The bar guide's nice and smooth. I do like the bar guide. That's good. So let's check the actual voltage. 5.3 volts. Nice. So let's look at amps. Does it warn? Yes, it does. It warns you about the lead connections. Excellent. So let's just plug in a lead, the correct lead, unplug that, plug it into the amps jack. So on amps and milliamps, does it automatically determine which one it is? It does, but it's defaulted to AC. Okay, pull the other plug out, plug it in that one, and it's switched over to milliamps AC as a default. So it's nice to actually knows which one you actually plugged into. That's a nice little detail. I like that. I think I would have preferred to have a DC default, but I suppose this is more of industrial use, so maybe AC is more likely to be used for this. Again, I'd like it to actually save this. See if I do a save of that. I don't think it's actually going to do much apart from save the reading. I think it doesn't actually save the setting. I'll have to research that some more and find out, but that's what it seems to do anyway. So microamps, that should be that jack as well. If I plug it into the other jack, yep, ignores it, that's fine. And that on there as well. Yep, so it has to be in the milliamp microamp jack in order to do microamps. That's absolutely fine. And that actually defaulted to DC. So you do have AC option as well. You can do AC microamps, but I think microamps AC is a pretty hard thing to measure. So DC to microamps is logical, that makes sense. Low ohms, it's warning about there being in the amps jack. And I'll check on that one. Yep, that's fine. And then we'll plug it into there. So low ohms can measure into the milliohms quite easily. Right, so it's a 50 ohm range. As you can see from the bar graph there, it shows up to 50 ohms. So let's actually hook this up to something and test it. So let's measure across the coil of an inductor. Why not? Here we go. 0.44 ohms. Nice. If I put the leads together, it does have a bit of a averaging in there, I think. Yeah, 0.65 or so. If I probe onto the actual pad, I do that. So that's like the meter zero. I suppose I could null that out. Yeah, it's alright. You can see low ohms there quite nicely. 2.8 ohms. The same over here. The others. There we go. Let's go short there, isn't it? 0.9 or so. Yeah, so that works alright. So let's go back to volts mode. We've got ranging, obviously. Manual ranging. 5 volts, 50 volts, 500 volts, 1000 volts. Back to 5 volts again. Hold it down, goes back to auto mode. So let's go in Johnson's PDV is too many here. If I can just turn it on. Let's do 10 volts. Let's do 1 volt first. Looks basically bang on. This still obviously got to warm up first. If I can just turn it on. 2 volts. Yep, bang on. 3, 4, 5. Let me get 50,000 count. So that should be right at the top end. 6 will change ranges. Yep, that's bang on. Up to 10 volts. Perfect. Only got 1 digit rounding there. But that's looking pretty good. Back to 5 volts again. Hasn't dropped down. Go down to 4, back up to 5. So it's getting pretty close. This has got to be on for a little while for it to settle. It's got a heated reference in there which needs to warm up. So this is getting closer and closer, so it's pretty good. That'll be not bad at all. A couple of counts down. We'll check this properly on my calibrator a bit later on. We'll hook up to my Datron calibrator. We'll go through, check AC volts, DC volts, AC current, DC current and resistance on the calibrator and see how accurate it comes out as compared to the specs which are provided here. So this is the calibration dial that they got. We'll see what we get. So it's also got hold functions as well, touch hold, min-max options. So each time it records a new reading it will beep. So I'll short it out, that's the minimum now. Actually I'll turn this back on, just put this away, let's just do some tests with this. 1 volt, there we go, beeps when I did that. Another one. So each time it gets a new reading it beeps, just to let you know it's got a new reading. So it's basically like an auto hold. If I come back down again, that's fine, it shows the maximum there. And also does averaging. Turn the backlight back on again. So you can see that base number of samples is going to gradually creep up. Okay, it's got restart. So that starts it again. So if you want to, once you got your connection set up, you can push that button and we'll start averaging from that point on. That looks pretty good, doesn't it, actually? So I was pushing this button here, so we got standard reading, got min max as we just looked at just now. You push it again, that actually stops the sampling, and then you can take the thing off and you can actually then review the samples. It's quite nice, and if you want to you can save it. And when you pause it, it does put this little arrow up here just to remind you that you're not necessarily sampling something, or you know, I don't know, but it's a little prompt, so it lets you know something else is different. Lightning symbol. So let's push the info symbol. Right, see what the info button does. So there we go. So whichever mode you're in, whatever function you're in, it tells you what the mode is and how to use it. What the actual functions do. So use it basically page down. Tells you what the buttons do. And a whole bunch of other general stuff too. Right. That's it. So there's the help information about the low ohm range, like 50 ohm range. So it uses a 10 milliamp current source. Nice information to know. I've got general other stuff down there too as well. Yep. I'll do the low Z range and then do info on that. What does it tell us about that one? So it uses a 3K range, backlight, 3 kilo ohm resistor for the low impedance input on the low Z version. So there we go. Goes voltages and improves accuracy in testing to determine absence of presence of voltage. Nice. So that built-in help is actually really useful, right? So if you don't remember exactly how the function works, what its configuration is, you can always pop into that and remind yourself what it does and how it works and how it may affect your circuit you're testing. Good feature. So we go into the setup menu. You've got different options here. You can do a reset, you've got display. So if I can do date, time or format, so date time, you can set the date time up, okay, do it in there. Or we go back over to format, you can change the display format to English, for example 24 hour, day, month format, you know, month, day, year. Or I actually prefer differently, I actually prefer day, month, year. So to me, I don't like that, I want to do this one. Let's change it around. Day, month, year. That's just my locale, alright, that's how I prefer it. Okay, number format, you can do dots or commas as well if you prefer that option. Alright, so now it displays day, month, year. Nicer. Calibration, I haven't looked at that menu yet. I'm probably, yeah, requires a password to calibrate. Sounds good to me. It's probably in the manual. Meter info. Calibration date 3rd of August, so it's 28th now. Only a few weeks ago. Pretty good. Apparently you can use the Fluke View forms which is a software they use to do things like add your name to it and add your company name to it and stuff like that. Contact information. Probably a good thing to do if you have a meter you're going to be taking out and about. Maybe you might lose it or something like that. So having that stored in the meter might be a chance you might get it back one day if someone finds it and they're honest. You never know. And it's got obviously memory built in for the graphing functions and logging functions. What else can we look at? Secure arrays, contrast setting, instrument, beeper on, dBm reference is 600 ohms, auto backlight timeout is 5 minutes. Oh, look at that. What can we change that to? 10 minutes. Oh, look at that. 15. Oh, lovely. Off, no backlight timeout, and 30 minutes. Oh, that's really nice. That is more like it. That's a decent backlight timeout. 10 minutes. That's the one. AC smoothing is currently turned off. Excellent. I like those options. So let's have a look at this logging thing, shall we? So I can do a save. So I'll show you got into right. So it's off the main screen off A mode, and I chose DC volts because it's convenient. It's one of my favourite modes. Push save. You've got a save option here, so you can just put save again. It will save that value into its internal log. Also have view memory, so let's view it. Measurements, recording, min, max, and peaks. Okay, what's this view measurements? There we go. There's a previous measurement there. Looks like there's only one there. Looks that way. Yes, delete it. Don't really care about that. Deleting save one, that's fine. Back to the save menu. Deleting, obviously that's for deleting anything that's in there. There's nothing there, so it's just bumped it back out. Probably. We'll have a look. View measurements. Delete all measurements. Delete all measurement data. Actually, let's drop out of that. Let's not do that yet. Recording. Let's do recording. Set duration, 1 day. Sample interview, so you got sample intervals or duration time, maybe it's both. So editing with days, hours and minutes you can log for. Okay. And or interval time, edit that, minutes and seconds, so you can log, you know, whatever time period you want. Right, that's handy. So maybe I'll do no minutes and just 10 seconds of logging. Okay? And we shall start logging this. Volts DC, and we'll just do some random stuff. Was it? Did I say? I said. I got that wrong. I did that wrong. Stop logging. So, clues, save option, record, sample interval. Let's edit that. Let's do 1 second sample interval, and duration. Let's change that time. I think it's obviously it's got a limit on how many samples you can take, how much memory it's got. Obviously, as in most things. So it's got 2 hours there, 47 minutes of a 1 second sample interval. So let's start logging with that. And it tells you how many samples it's taken down here. And we'll just look at this and we'll play the probes a little bit. Get a few samples off it. Doesn't really matter too much, does it? It's going to be really erratic and noisy. Okay, we'll stop sampling that. So let's look at the trend chart. We could save it as well. I'm not sure how we're going to go with that. Save it. And trend it. Okay, there we go. And there's the graphing of the actual readings. Isn't that nice? It's got a summary. Tells you about how many samples it took. Yep. Right. It's got some logs as well for the date and time, what have you. That's really nice. And easy to use. Didn't even have to read the manual. And there's a slightly better view of the screen. You can see it's got volts DC down one side there. It's got the scale, because it's going up and down, so I was just touching the probes and generating noise, stuff like that. So obviously it's got a time scale here as well for how long it's sampling for. And obviously each digit. So I think I can probably scroll through, can I? I can. Look at this. I can actually look at each sample and see what the actual values are individually as well at the bottom of the screen here. So let's come over here. Let's look at that low peak there. It's minus 1.8. And go to the high peak, which is there, plus 2.3. So you can actually examine each one as well with the timestamp. That's nice. But wait, there's more. See over here, there's another arrow indication, times 1, times 2, look, you can zoom in, times 3, times 4, times 4 is the maximum you can do. So you can zoom into the sampling as well and look more closely at it. So is that an actual sample there? It's each sample there. Look at that, you can scroll through it. Nice. So if you've got loads and loads of samples, you can zoom in. Well, I'll show you this actually. I never went into this one. So the temperature option on millivolts, went into the menu, chose temperature, degrees C. And I'll just turn it back off because I already had it on. Degrees C. And right now it's showing open thermocouple because I don't have a thermocouple plugged in. But I'll show you something. Short little leads together. These are meters temperature, 24 degrees. Because they have a thermocouple built in as well, which gives it a reference point. So you stick the leads together, you actually get a temperature. Maybe you didn't know that. So I think the next thing we should do is go to the calibrator and go and check out these things in a bit more detail. So, to the calibrator. So let's check this thing on the calibrator. I'm going to start DC volts. I'll do some low voltage stuff first, just to establish some baselines, and then we'll look at the millivolts range, and then we'll do the high voltage stuff, and then we'll do AC volts and stuff as well in a similar way, I expect. So set at 1 volt, output on at 0 volts. So I should be seeing 0 volts here, and we basically ask, got a little bit of rounding going on. 1 count sometimes flicks up. So let's do 1 volt. Look at that, perfect. I'm going to go downwards first. 1 millivolts is perfect. 10 millivolts is perfect. 1 millivolt is perfect. Don't forget you got that 1 digit flicking up before. 100 microvolts, perfect. So this is still flicking at 1 digit. So yep, that's looking really good. So let's do the millivolt range now. We're down here. Yeah, so 100 microvolts is showing up as 88. Okay. Bit out there. 1 millivolt is reading as 98. Don't forget on the volts range it was perfect. So we've got a bit of a discrepancy there between those ranges. So 10 millivolts is also reading 9.98. A couple of counts down, or I suppose you can say 1 count down really. And 100 millivolts is 99.98. So this is reading down by a couple of counts on the millivolt range. Volt range, as you saw, was looking really good, but millivolts is slightly out. I'm surprised. It's not out by much. I'm sure it's well within spec. It would have been nice to be a bit more precision than that. Okay, let's go back to volts range. Let's do 10 volts. That's perfect. 100 volts. 100 volts is 1 count high. That's fine. So it's actually drop this down to say 300. So 300 volts. 1 count high. That's not bad. 500. Don't forget it's a 50,000 count meter, so it's the top of the range. 1 count high. That's good. So 600 will be the next range up. Here we go. So now in the 1000 volt range. And it's also 1 count up. 800 is 1 up. 1000 is 1 count up. That's alright. In fact, 1000 is now perfect now, so a bit of chance to settle. So now it's generating 1 millivolt at 1 kilohertz on AC. And we're getting 0.98 again. Sounds familiar, doesn't it? A couple of counts down on the millivolt range. The 10 millivolts is like 1 count down a little bit there. Well, 18 counts down I suppose. 100 millivolts, a couple of counts down. Let's try doing frequency while we're down here. Let's do 100 hertz. 100 hertz is basically perfect at 100 millivolts. Okay, 10 millivolts at 100 hertz is perfect. Okay, so it's a bit of a frequency dependent thing. And 1 millivolt is still reading low. So let's switch to the AC range on the actual main voltage. So 1 millivolt should be showing 10 counts on here. And we're not seeing it at 100 hertz. Let's try 10 millivolts. And we're still not seeing it. Okay, I would have thought I would be able to see 10 millivolts, seeing as it actually has that resolution. Let's change frequency to 1K in case it matters. No, it didn't help. So 100 millivolts at 1K is reading about 20 counts down. So that's why we couldn't see the 10 millivolts, because it's below that. It's being rounded off to 0. So also the very bottom voltage calibration is a little bit off. And 100 hertz is the same. 1 volt, 100 hertz looks basically perfect. Within a count or so. 1 count, look. It's there. Once it's settled down. 10 volts, So 10 volts as it's settled, it's about sort of 1 to 2 counts out, 100 hertz. I'll change frequencies and come back down again when I get to the top. So 100 volts. Give some settling time. Yes, 1 to 2 counts down at 100 volts. Okay, let's do the same 300 volt test. It's got a lot of settling time on there. It's obviously using averaging of some kind, even though it does have averaging as an option, I think, but that was turned off. So it's obviously got some other averaging built into it. Smooth the readings out a little bit. So about 7 counts high, not too bad. 500, so that's top of that scale. 14 counts out. Let's just watch the bar graph, see what happens when I change ranges. So it reacts fairly fast. Don't forget some of that delay will be the actual calibrator changing. Alright, 600 volts. Yeah, a couple of counts high. 800 is about 3 counts high. And 1000 is about 3 counts high as well. Let's change frequencies. So I've changed frequencies to 1 kilohertz now. And we're now reading slightly low instead. So I go down to say 500 again. So I'm going to go 400 then 500. So it goes to the top of that scale. And that's reading down a little bit. And 50 volts. Yep. Let's do 100 volts there. So 100 volts settled down to be sort of 4 or 5 counts, sort of 6 counts, 7 counts maybe below. Okay, so 10 volts is a few counts down. 1 volt is about 5 counts down. And back down to 100 millivolts, which we saw before, is a couple of counts down there. Well, 20 odd counts down, something like that. Let's try different frequencies. Go back to 1 volt. And I also look at the frequency response on this thing, and I always do this at 1 volt. This is a nice reference voltage. Should be enough for it to sense properly without being overdriven and inducing other problems. So let's do 10 kilohertz. So that's down a little bit there. So 100 kilohertz. It's down a fair bit there. 1 megahertz is a long way down, so I don't seem to sense too well down there at all. Let's try and find out where that point is, where it actually starts to look like it's doing okay. I mean, we're supposed to do 1 volt here, so it's a long way off. $200K is getting close. So I'm not quite sure what the spec actually was. I haven't actually looked up the specs on this thing, to be honest. So let's say 120 kilohertz is about 4% down. How does that sound? It's probably a typical spec, isn't it? So now let's check the bottom end. So I've changed to 100 hertz. You can see that's looking pretty good there. So let's bring it down. See where it starts to drop off or misbehave. So 50 hertz is still looking pretty good there. 30. Still okay, dropping off slightly. 20 is dropping off a little bit. And 10, which is as low as I can go. 10 hertz, and it's still reading it okay. It's really started to get a bit of variation because of obviously the fact the waveform was quite slow at 10 hertz. So next thing we should probably look at is actually the things like hertz. So let's actually do hertz measurement, which is here. Hertz. And let's see what this thinks about frequency. So doing 10 hertz right now, and it's, yep, that's fine. 100 hertz, bang on. 1 kilohertz, bang on. 10 kilohertz, bang on. 100 kilohertz, yep, bang on. 1 megahertz, can't see it. That's not unsurprising. Okay, let's bring this down so they can see it. So 300 kilohertz is most you can see with that particular voltage. Let's increase the voltage. That does make a difference in most cases. There you go, 500, that's up there much higher now. So 1 megahertz, can't see that, it's over range. 900 kilohertz you can see. So it's like basically not 1 megahertz is the most it can do. That's right, you can see it, and it's pretty accurate. So I thought let's check duty cycle. And we're getting 51% here. Now I've actually seen this kind of reading a few times on different multimeters. So I'm just seeing doing 1 kilohertz at 1 volt. I've changed it back down again now. So it's got perfect frequency, and I've got a slight imbalance here on the duty cycle apparently. So it's interesting, as in this may actually be correct, because I've seen this about 51% on a couple of multimeters now. So I'm actually thinking my duty cycle might be slightly off on this calibrator. So next thing I think I'll look at actually is we've got a low pass filter here. So let's select that, Low pass filter and hertz. This can do dual display. So you can see it's cutting us off. Yep. So I want to find out what the frequency cutoff is of this. So let's go down 100 hertz. I expect it will see that. It doesn't. Okay. Still doesn't see that either. Interesting. I would have thought we would have seen mains frequency. Let's try going higher. I thought it was a low pass, maybe it's a high pass. 10 kHz, can't see that either. Let's increase the voltage. 10 kHz, can't see it. Usually low pass filters about 1 kHz. A lot of meters anyway. And this mode. And nothing. It's barely registering anything. That's 9.7 volts AC. It's starting to show up now, 100 Hz. I wonder if there's an option for this or something. Okay, so it does have a filter, but I'm probably not using it right. So back to that, and we should be back again. Interesting. So let's change over to crest factor. I'm seeing 1.4 here as a crest factor. And back over here, we've also got peak measurement. Let's look at that. And it's saying no. I want to do peak measurement. I don't know. Why is it an option if you can't do it? I don't know. Weird. I don't know. There's still things I don't understand about this MIDI. I haven't got used to it fully. Anyway, that's that part. Now we shall check resistance. So I've got it set up for 0 ohms right now. Output is turned on. You can see getting 0.47 ohms here, which is combined resistance. So obviously we've got this slight offset. If I short out with this little short here, directly across the meter input, you can see we're getting right down to basically 0 ohms, 0.01. And while I'm here, actually might go down to the 50 ohm range as well. There's a 50 ohm low ohm range, which is settling down. So there you go, the low ohm range actually settles down to a negative value. That's interesting. It's even better than what the factory had for a short then. We'll take that back out. We'll short it back across the input of the actual calibrator, which will change things a little bit, because that's then the lead resistance. We get about 0.1 ohms there on that range. And back on resistance mode, we're getting about 0.13 ohms as a short directly on the input to the calibrator, or the output of the calibrator. And obviously, so we're getting about 0.3 ohms through the calibrator circuitry. We could null that out. I'm going to leave it as is. So, 10 ohms. Well, we've got 10.42 here. Don't forget we've got a slight offset of 0.4, which isn't really factoring in here. This may actually be accounting for that offset. I do actually have my Fluke calibrator up here. I might actually flick onto that as well afterwards. So 10 ohms is very close. Lead resistance and stuff like that are a bit of an issue when you've got things like this, which is just a 2-core lead. It's only doing 2 wire resistance, don't forget. That does affect the readings a lot. 100 ohms is basically right, so you have a very little difference there, again because of lead resistance and so on. Mind you, lead resistance was 0.1 ohms, wasn't it? Lead resistance. So, what was it, 0.13? If you factor that in, it's actually going to be about right. So if I actually shorted out the lead resistance and then did this test again, these would be basically bang on, I think. So 1k, again very slightly high here, not much. 10k is 5 counts up compared to the calibrator. That's actually surprising. So 100k is 4 counts up, 1 meg is basically right, it's 1 count out basically. 10 meg is basically right, 1 count, so it's actually looking pretty good there. And 100 meg, which a lot of meters can't actually read, only the better ones can, and this is reading it. Also see rounding up a little bit here, it's like 0.04, it should be rounding down, it should be 0 really I suppose, but you did see it flicking around slightly before, so it's basically right. It's going to be ballpark, it's close. For 100 mega ohms on a 2-wire measurement, that's alright. So I've just plugged into my Fluke calibrator, which has got a 100.0265 is the actual reading, and it's still reading 0.1. So yeah, that's actually fine. And 10 meg, we get in there. Calibrator is 9.9998. So yep, it's very slightly high as I suspected. 1 meg, is 1 count high because this is 1.4035. I could change the camera so you can see both, but I'll just tell you what they are. This is 100k, which is 4 counts high on the meter here because it's 100.0028. 10k is 5 counts high as per my Datron calibrator here. This is just confirming the Datron is doing the same thing. This is saying 3 counts high, so it's 1.000253. It's 3 counts high. Let me recheck this one. Yeah, 3 counts high. That agrees. No worries at all. Just doing a second verification, just in case I've got a bad relay, because it can happen. I've had to repair relays on this Fluke calibrator before. 100 ohms is about 14 counts high. Lead resistance sounds familiar, doesn't it? 10 ohms is 14 counts high. 13.3 counts high because it's 10.177 on the meter here. Again, lead resistance. 1 ohm is 1.17, so it's about 11 counts high. So there's not much in it. And I've got a short here is 0.175, and that's 0.35. So it's very slightly better than this calibrator does for a short. Not much in it though. It's all good. Now let's do microamps DC. Got the output 0. We're getting 0. Still 100 microamps. It's pretty good. 5 counts out. 1000 microamps, or 1 milliamp. That's 3 counts out. That's alright. What's the max on this thing? 5000. So if I go up to the next range up, it's going to overrange. Yes, it is. Let's bring this down to 5000. And there we go. They're sort of 10 counts high there. So let's go to milliamps. And 5 milliamps is looking perfect. Let's go down to 1 milliamp. Actually, I'll start at the bottom. We'll look at the whole lot. See how it handles it. So 100 microamps, you can see it just fine. 1 or 2 counts up. 1 milliamp. 1 or 2 counts up, it looks like. Maybe 1 count up. Yeah, 1 to 2 counts up. 10 milliamps. Look at that. Basically perfect. 100 milliamps is a couple of counts down. I can't do the next one up because I was I'll blow the fuse. So let's change cables and do the amps jack. So I've just extended the cable. I'll just put another cable in series with it so I can just use that. It's just easier because I do want to go back to the other cable. So 100 microamps, it's kind of showing up there. If I do 0, that extra 1 count, it does show up. There you go. 1 milliamp is 1 count up. 10 milliamps is 1 or 2 counts up there. I suppose you call it 1 count. That's settled. 100 milliamps is kind of 1 count up, I suppose. 1 amp is pretty much perfect. Yep. And the most I can do with this is 1.9 amps. And that's just a couple of counts down. So let's do AC before I change cables around and do to the big calibrator. So I've changed over to AC amps now. So I'm on my milliamps range. 1 milliamp I'm doing here. I've changed the meter over using the menu button here. And you can see we're about 9 counts up at 1 milliamp at 100 Hertz. 10 milliamps is out of scale on the microamp range. Milliamp range. So 10 milliamps is a couple of counts down there. So maybe 3 counts, let's say. 100 milliamps, you're just looking at about 4 or 5 counts up. Let's change frequency to 1 kilohertz, and that's actually looking pretty good there. Let's change to amps. So 100 milliamps, 1 kilohertz is reading a few counts down, well 20 odd counts down I suppose you could say. 2 or 3 milliamps down. So 1 amp is also about the same kind of effective scaling, about 3 milliamps down, 2 to 3 milliamps. Let's go to max, and you can see we're about 3 milliamps down still at 1 kilohertz. Let's do 100 hertz and we'll go back down again. Looks about the same, slightly better. Let's do 100 milliamps. Yeah, it's basically the same as it was before the other frequency. Now I do actually have a high current calibrator up here. It's a transconductance amplifier. So I need to hook up to that and we'll do something a bit more than 1.9 amps. So I've got this set up on the 1 amp range, and we'll just do 1 volt into the transconductance amplifier on DC. So 1 volt should give us 1 amp, and we are indeed getting that. Great. So let's go to the 10 amp range. We shall wind this up 100 millivolts at a time. Now my transconductance amplifier is not warmed up yet. It should warm up for about an hour or so really, and I've only had it on for a few minutes, so it's not going to be perfect. But let's just give you an indication of rough accuracy. It's within a few counts, isn't it? A couple of counts there. Yep. 10 amps flashing to say it's maximum range. Okay, so that's alright. Now for some reason we're finding with this transconductance amplifier, although I've repaired it, it was working fine anyway. It's actually overloaded my calibrator. I try and do AC. So I'll stick this on AC. We'll do AC on here. We'll turn the output on. 10 amps AC, there we go, it's doing it. Right, so there we go. 9 amps AC, absolutely fine. Now I'm getting the error. Overload errors. So yes, it's not liking it for some reason. I meant to look at this whilst I was doing the calibration checks on the calibrator. Anyway, I completely forgot. But one of the recent one is the amps DC, 5 amps, which we just did. And remember, we were reading a few counts high, and sure enough, at 5 amps we are reading a few counts high. So it does correlate, at least in that regard. Volts AC, I mean these are just a verification, right? So this is just a check. This is an actual calibration record. This is just a product verification, which does give you at least an indication of accuracy. You've also see we're reading slightly down here. Yes, you were seeing that at 10 kilohertz. 100 kilohertz is the next check it did there. Millivolts AC, 20 hertz was reading down slightly. 45 hertz is reading down slightly. There's that 98 number. So yeah, that's confirming that what I'm seeing on my calibrator is basically matching what they got. So I'm pretty happy with that, and also the volts and stuff like that. DC ranges are pretty good. The millivolt AC one's an interesting one. It's showing 5 millivolts there, but we couldn't see that on the volts AC range. So the lowest that it goes on here is 500 millivolts on the volts range. So and then you can see it's reading down by 3 millivolts. That matches what we found. Right, let's do the screen peel. Let's hope you're ready for this. Don't get too excited now. Saving the best for last. Oh yeah. Well, the next thing we should do is pull this thing apart. Might be an over-moulded case. Hey, is that screw already out? There. That one's already... See, that one's recessed. This one's really close to coming out. Is that already undone? That's not a screw. It's tight. It's weird the way it sits differently. Well, it was tight, but it wasn't actually screwed right down. It was only half screwed in. Interesting. Anyway, let's get that one out. So, plastic screws. Do that. Let's get this open again. There be screws behind there, I'm sure. Yep. So 3 more screws, 4 more screws, yep. Get those out. I mean, these shouldn't really be an issue, the fact they're plastic screws rather than metal threaded. I mean, the batteries are accessible, as are the fuses, without taking the casing apart. So, in this case, plastic screws is perfectly fine, because you should never need to get inside this thing, really. Unless you're doing what I'm doing and having a bit of poke around. Right. How do we get this apart? It's a bit tight. Spudger. Spudgers. Right, got some progress. I've got some in the middle. There we go, it's starting to get some movement now. Let's wedge it in this way because it might be better. You know what I need? I need some thick spudgers. Maybe something more like this. So it does stick together really well. It's a very tight fit. Surprisingly tight. I'll come back when I'll get it apart and I'll tell you how to do it. It fought me all the way, but I'm getting there. There we go. Wow, screw which didn't fall all the way out. That was a struggle all the way out. That's an incredibly tight shell, very tight clamshell. That's because it's got this really deep channel in here, which is obviously blast protection sort of thing, you know. It's all there for safety and, you know, keeping the dust and stuff out of it as well. So we've got screw terminals on here. Let's check these, see if they're tight. As expected, all good. So there's the two fuses we saw before. There's terminals here for the battery. So the terminals are there. There's a ribbon cable goes around, probably for the keypad. Or it could be something else, I'm not sure. I'm not going to take the whole board right out. We've got a shunt over here. Position resistor just there. Some big PTCs, feasible resistor. Some MOVs under there in this little shielded section. All looks nice enough. Position resistors, protection diodes and stuff over here, it looks like. Sensing circuitry is down here as well. Obviously got cutouts in the board, which appear to actually have this protrusions go into the board, so these go into those cutouts. So it's actually got extra protection. All looks nice enough. I'm not going to pull it apart any further than this. But yeah, nothing there to be concerned about, certainly. It's a Fluke. All looks fine to me. I do, however, have one slight concern. So you've got these posts that are sticking up here. You can see there's that one which had that screw. You can see the thread from the screw was cut into it all the way down. And you can see that only went in a couple of threads. This is that one which is protruding slightly, so it was screwed in a bit, but wasn't all the way down. Now, this appears to be like polycarbonate or something like that. I'm not sure exactly what it is, but what worries me is that these translucent plastics, they often will get more brittle sooner rather than later. And as it's just a post like this, putting all that stress in it because it's got a plastic screw forcing its way in there, cutting a thread in, that's putting a lot of outward stress on that post. And what that will potentially do is cause these posts to split and break. So that's my only concern with the actual assembly of this. I mean, the other screws were fine. It's just these top two which are a bit of a worry to me. I'm just not sure those are robustly designed for longevity. I mean, I think they probably last, you know, 5-10 years without a problem. You know, anything after that I'll be expecting to think maybe it's going to start going, because the other thing is plastics shrink with age, and when you've got a screw going into these, any kind of screw or anything on it which is plastic is moulded around even, as it shrinks it's got nowhere to go because the screw is in the way, and something has to give. And the plastic will split. You're talking years and years, right? It's not going to be like it happens next week sort of thing. This will happen in 10, 15 years time kind of thing, maybe 20 years. Is that going to bother you? Probably not. I just think about these things, you know, because if this was completely encased or had a larger area around it, or was a softer material, not this translucent material, then I'd be less worried about it. This is quite a rigid material, which means it doesn't have much give in it. And that's when they tend to split. If it is a softer material, then it wouldn't really split. It would just harden up slightly, and even if it shrinks, it's still got some give in it. It won't matter. But this will potentially be a problem. But anyway, I'm just nitpicking a little bit there. It's not likely to be a real problem at all. Another little nitpicking thing: these two centre screws don't actually have much bite. That is it. That's just touching on the end of the threads. Now, what you're supposed to do with a screw, these plastic screws, is wind them backwards, like that, so it drops into the threads and then you screw it in. But the thread on this is literally one turn of the thread. It's not much there at all on those middle ones. These screws really are a little bit short for those. Bit of a shame. Does it matter? Probably not. Based on how tight the case was to actually get the part, realistically it probably doesn't matter. But I just think it should be slightly longer. So there you go. That's the video on the Fluke 289. I really like this meter. I'll finish putting it back together soon. I like it that much, I'll put it back together. It is big, it is a bit bulky. I mean, it's bigger than the 87.5, I think. And but it's got some really nice functions in it. I mean, it's not a cheap meter, but it certainly seems like it's really good quality and has a really good feature set. This may become my main bench meter. We'll see. You probably don't care about this too much, but for me, having a multimeter which I can see on camera is quite important. So when I'm doing stuff on the bench, I can actually show you the readings I'm getting and things like that. So the 175 I've got here, which is, you know, although it's not my best meter, it's a good meter. It's not the best one I've got. This shows up on screen really easily. You can see the display really well, which is why I use this one as one of my main meters. So hopefully I can get this one to be just as good. I think it's not quite as good to see on camera. Depends on the lighting, but it's not bad. So this may become my main meter. We'll see. I'm certainly very happy with it. The only thing is that I've got a small gripes about is, say, those screws, those ones being a little bit short, and not as, say, those posts like I was saying before on the teardown. And I don't know what the battery life is like on this thing yet. I should really investigate that and just see what the specs actually say, and then take off 20% or something, real world performance. And the other little thing is the menus, having to go to menus to change modes. Like, you know, you've got these multiple modes. You know, if you want to go between AC and, well, like on the amps ranges, for example, you've got to go into the menu. You can't just push a button on here. So I don't think you can anyway. Maybe it's possible, I just don't know how to use it. It's possible, it certainly is possible. But yeah, I don't know, it's not really much to gripe about this. It's a nice meter, I'm very happy with that. So thank you much Fluke and Pomona, because Pomona arranged for me to get this from Fluke. I mean, I'm really appreciative of the suppliers that will send me things for free, so I can sit down and do a little video on it, and I can get these bits of free test gear, which are, you know, really nice to have. You know, even, you know, the lower, cheaper budget stuff, which I get from time to time, that's still nice to get, even though I've got this high-end stuff. You know, because those are more widespread, so my viewership is more likely to see those kinds of things and go, oh yeah, I'll get one of those cheap meters because it's 20 or 30 bucks or whatever. Obviously this is a professional grade meter, so this is significantly different and significantly better. It's obviously going to be a limited market for my viewership, but anyway, I appreciate the support I'm getting from Fluke and from Pomona. They've been really good for me. I've been surprised at how generous they've been with me, actually, to be honest. Thank you, person sitting there looking at the screen right now, for watching this video right to the end. Your support helps my channel immensely. YouTube will see you watching the video to the end, and they will then potentially offer this video to more people. More people to watch this for longer times and for longer durations without skipping through too much and that sort of stuff. YouTube recognises that and actually helps to decide whether or not to promote the video or not. So anyway, that's a side anyway. So I think the only other thing I'm really thinking about on this is a little bit, I don't know, what's the word, surprising, slightly surprising, is that difference in the DC millivolts and the AC millivolts, and especially like the low millivolts AC on the AC range, where it just didn't show up because it was below this rateable range, because it was basically scaled down. So I wouldn't get noise at the 0 volt level, which is quite a common thing. A lot of multimeters aren't actually calibrated at 0 volts on AC. They're usually calibrated something like half a volt or 1 volt, or could be 100 millivolts P on the meter. And because of that offset, very bottom end can actually just drop right off with, you know, just the noise and filtering things like that which are built into them. So, but yeah, it'd be nice to actually have the AC slightly more sensitive on the milliamps and just fix that slight calibration error there. It's not much. I mean, I'm sure it's still within spec, but I'm fussy. It has to be perfect. And check the other multimeter reviews out, which would be there somewhere probably. So yeah.